This is section 9.5, Oblique Triangles, the Law of Science. So let's see what is an oblique triangle. An oblique triangle is a triangle that does not have a right angle. Before, we solved right triangles using trigonometric functions, but in this section we will solve oblique triangles. Here we have the law of science that says that in any triangle, the sides are proportional to the sines of the opposite angles. Below, we have an oblique triangle with the angles A, B, and C. As you see, for the angles, we use uppercase letters, and none of these angles are right angles. Now, let's talk about the sides of this triangle. The side opposite of angle A is called side A. The side opposite of angle B is called side B, and the side opposite of angle C is called side C. As you see, for sides, we use lowercase letters. Now, the law of science states that side A divided by sine of angle A is the same as side B divided by sine of angle B, and this is the same as side C divided by sine of angle C. We will use the law of science to find missing sides or angles in a triangle. As you see here, this law is an equality of three fractions. However, when we will need to apply it, we will use only two fractions at a time. For example, we may be using the first fraction and the second, or the first and the last one, or the second and the last one. There are some specific cases when we can use the law of science, and this is what we will discuss next. The first case is the SAA triangle. This is side, angle, angle, triangle. This means that in a triangle, we are given one side and two angles. One of the angles is adjacent and the other one is the opposite. The next case is ASA triangle, that is angle, side, angle. This means that in a triangle we are given an angle, a side, and another angle. As you see, both angles are adjacent to this side. The third case is the SSA triangle, that is side, side, angle. This means that we are given two sides and an angle that is opposite to one of these sides. This case is also called the ambiguous case, and we will talk about it later in this section. Now, let's solve some exercises where we will apply the law of science to solve oblique triangles. Here we have exercise 3 on page 288. We are given side A, that is 45.7, angle A, that is 65 degrees, and angle B, that is 49 degrees. We are asked to solve this triangle. That means that we will have to find angle C, side B, and side C. Let's start by drawing the triangle. That will help us visualize what we have and what we have to find. So here we have the triangle. Let this be angle A, and this angle is 65 degrees. This one, angle B, and it is 49 degrees, and then the missing angle is angle C. Side A is the opposite of angle A, and it is 45.7, and we will find sides B and C. As you see, in this triangle, we are given one side and two angles. One angle is the adjacent, and the other one is the opposite to this side. We can say that this is SAA triangle, side, angle, angle. So now let's solve this triangle. We will need to find angle C, side B, and side C. Just like when solving right triangles, there is not necessarily only one way of starting this problem. We could start it by finding a side, or we could start it by finding angle C. To find angle C, we need to subtract the other two angles from 180 degrees. So let's do this first. Angle C equals 180 degrees minus the sum of the other two angles, 65 and 49. Then angle C equals 66 degrees or 66.0 degrees to keep the same amount of significant digits as the given angles. Now to find side B or C, we will use the law of sines. Again, the law of sines states that A over sine of angle A equals B over sine of angle B equals C over sine of angle C. And to solve for a missing side or angle, we will use only two fractions at a time. In this triangle, we are given side A and angle A. We are also given angle B, and we can use these two fractions to find side B. So again, we will use the law of sines A over sine of angle A equals B over sine of angle B to find side B. We will replace A with 45.7 over sine of angle A, which is 65 degrees, equals B over sine of 49 degrees. To solve this equation, we will use cross multiplying. We will multiply B by sine of 65 degrees and then 45.7 by sine of 49 degrees. So then B times sine of 65 degrees equals 45.7 multiplied by sine of 49 degrees. We will divide both sides by sine of 65 degrees. On the left side, sine of 65 degrees will cancel, and B will be equal to 45.7 sine of 49 degrees over sine of 65 degrees. We will use the calculator, and we will get that B is approximately 38.1. Now we have to find side C. If we look at the law of sines, in the first fraction we know side A and angle A. We also found angle C, which is 66 degrees, and we have to find side C. So again, to find side C, we will use the first fraction and the last one. A over sine of angle A equals C over sine of angle C. In place of A, we will write 45.7 over sine of 65 degrees equals C over sine of 66 degrees. So, as you see, each of these equations have 4 variables, and if we know 3 of them, then we can solve for the unknown one. From here, we will use cross multiplying to solve for C. So, C times sine of 65 degrees equals 45.7 times sine of 66 degrees. We will divide both sides by sine of 65 degrees. On the left side, sine of 65 degrees will cancel, and C will be equal to 45.7 times sine of 66 degrees over sine of 65 degrees. C equals approximately 46.1. So now we have angle C, side B, and side C. Now we will continue with another problem. This is exercise 5 on page 288. In a triangle, we are given side C of 4,380, angle A of 37.4 degrees, and angle B of 34.6 degrees. Let's start by drawing the triangle. We will have the angles A, B, and C. Angle A is 37.4 degrees, angle B is 34.6 degrees. and side C equals 4,380. In this triangle, the left side will be side B and the right one side A. By the given information, we can say that this is an angle, side, angle triangle. That is A triangle. And what is missing in this triangle is angle C, side A, and side B. Let's write down the law of sines to have it handy. That is A over sine of angle A equals B over sine of angle B equals C over sine of angle C. At this point, it looks like I can't start with the law of sines because if I look at these fractions, in the first one, I don't know side A, I know angle A. I don't know side B, I know angle B, and I know side C, but I don't know angle C. So in this case, we have to start by finding angle C. Angle C equals 180 degrees minus the sum of 37.4 degrees and 34.6 degrees. Angle C equals 108 degrees. Once we know angle C, one fraction that we will use for sure will be the last one, because in this one we know side C and we know angle C. So if we want to find side B, then we will use this fraction and the last one. So B over sine of B equals C over sine of C. Then B over sine of 34.6 degrees equals, in place of C we will write 4,380 over sine of 108 degrees, because we just found that C is 108 degrees. From here we will use cross multiplying. First we will multiply B and sine of 108 degrees, then we will multiply these two numbers. So B times sine of 108 degrees equals 4,380 multiplied by sine of 34.6 degrees. Divide both sides by sine of 108. On the left side, sine of 108 will cancel. B equals 4,380 sine of 34.6 degrees over sine of 108 degrees, and B will be approximately 2,620. Next, we will find side A. For this, we will use the first fraction and the last one. But if we wanted, we could also use the first fraction and the second one, because in the second one we know angle B and we just found side B. I will still go with the first fraction, A over sine of angle A, and the last one, C over sine of angle C. From here we will replace and we will solve for side A. A over sine of 37.4 degrees equals 4,380 over sine of 108 degrees. Then A times sine of 108 degrees equals 4,380 multiplied by sine of 37.4 degrees. We will divide both sides by sine of 108 degrees. On the left side, sine of 108 degrees will cancel. A is equal to 4,380 sine of 37.4 degrees over sine of 108 degrees. Then A will be approximately 2,080. 800. So we just found all the missing dimensions, and these are angle C, side B, and side A. Now let's talk about the ambiguous case, side, side, angle, triangle. Here we have three cases, and in each case we are given two sides A and B. We are also given angle A that is opposite of side A. So when we are given two sides and one angle that is opposite of one of these sides, we may be able to form one triangle, we may not be able to form any triangle, or we may be able to form two triangles. In the first triangle, we have side B, side A, and the height of this triangle. If this side A is greater than side B, and it is also greater than the height, then one triangle can be formed. Also, it is important to remember that this side that is greater than side B and then the height has to be the side that is the opposite of the given angle. In the second case, side A is opposite of the given angle A, and side A is less than side B and it's less than the height. Then, in this case, no triangle can be formed because this side is too short to close and form a triangle. But in the third case, if side A is less than side B, but it's greater than the height, then two triangles can be formed. And that is because this side A can be closed to the left of the height or to the right of the height. So then, one of the triangles formed could be this one, and the other one could be this one. Now let's solve some examples involving side, side angle triangles. This is exercise 9 on page 289. We are given side B and it equals to 7,751, side C is 3,642, and angle B is 20.73 degrees. Let's start by drawing the triangle. Then let this be angle A, this one angle B, and this one angle C. Then opposite of angle C, we will have side C, which equals 3,642. Opposite of angle B, we will have side B, and it equals to 7,751. Angle B is 20.73 degrees. So what we have here is side C, side B, and the angle that is opposite of side B. So we have the case side, side, angle. Now the question is, if we have side, side, angle case, will we end up with one triangle, two triangles, or no triangle at all? Now, if we recall the rules of the ambiguous case, then if the side that is opposite of the given angle is greater than the other side, then we will end up with one triangle. Now, what we have to find in this triangle is angle A, angle C, and side A. And in the triangle, side A is down here. I will also write down the law of sines, and now we will determine what part we could find first. In this triangle, we are given side B and angle B, and this means that we can use this fraction. And we are also given side C, and we could find angle C. And this means that we will also work with this fraction. So B over sine of angle B equals C over sine of angle C. Now we will start replacing. In place of B, we will write 7,751 over sine of angle B, which is 20.73 degrees, equals side C is 3,642 over sine of angle C. We will do cross multiplying. Then 7,751 multiplied by sine of C equals 3642 multiplied by sine of 20.73 degrees. Let's divide both sides by 7751. On the left side they will cancel, and sine of C equals 3642 sine of 20.73 degrees over 7751. Now to find angle C, we will take sine inverse of all this fraction on the right side. Then angle C will be approximately 9.574 degrees. Now, once we know angle C and angle B, we can find angle A. Angle A equals 180 degrees minus the sum of the other two angles, 20.73 plus 9.574 degrees. Then angle A equals approximately 149.7 degrees. Now, once we know angle A, we can find side A. For this, we will use A over sine of A equals B over sine of B. Now, let's replace A over sine of 149.7 degrees equals, in place of B, 7751 over sine of 20.73 degrees. We will use cross multiplying, so A will be multiplied by sine of 20.73 degrees, and 7751 will be multiplied by sine of 149.7 degrees. We will divide both sides by sine of 20.73 degrees. On the left side, they will cancel. Then A equals 7751 multiplied by sine of 149.7 degrees over sine of 20.73 degrees. Then A equals approximately 11,050. So we found angle C, angle A, and side A, and now the problem is completed. On exercise 16, page 289, we are given side A of 89.45, side C of 37.36, and angle C of 15.62 degrees. We see here that side A is greater than side C, and angle C is the angle opposite of this side. Let's start by drawing the triangle. Let this one be side A, and A is 89.45. Then we have side C, which is a shorter side, and C is 37.36. I am not sure how big this angle should be when I draw this triangle, but that is okay. But I know that the angle that is opposite of side C will have 15.62 degrees. So let's form the triangle, and this angle will be angle C, and it will measure 15.62 degrees. Also, opposite of side A will be angle A, and opposite of side B will be angle B. Now, based on this given information, we can tell that we have a side-side angle triangle. We also see that the side that is opposite of the given angle is shorter than the other side. And this means that we may end up with having no triangle at all, or having two triangles. Now then, how can we tell if this problem will result in no triangle or two triangles? It all depends on the height of this triangle. If it happens that side C is shorter than the height, then this side would not reach the bottom and we would not be able to close and form a triangle. But if side C is greater than the height, then we would have two triangles because we would be able to close this side C to the right of the height or to the left of the height. We can find the height even before we try to solve the problem. If we look at this triangle, then we can say that sine of 15.62 degrees equals the opposite side, which is the height, divided by hypotenuse, which is 89.45. So sine of 15.62 equals h divided by 89.45. If we multiply both sides by 89.45, we will get that h equals 89.45 multiplied by sine of 15.62 degrees. Then h equals approximately 24. Now we can clearly see that side C is longer than the height. And this means that with the given dimensions, we can draw two triangles. One of these triangles will have the side C to the right of the height, and the other triangle will have the side C to the left of the height. Here I will draw the side C to the left of the height, and the second triangle formed will be this one. Now, if side C, side A, and angle C is the same for both triangles, the dimensions that we have to find, like angle A, angle B, and side B, will not be the same. For example, for this big triangle, this is going to be angle A, but for this triangle, this is going to be angle A. Or if for the big triangle, this is side B, for this triangle, this is going to be side B. We will start by finding the dimensions of the big triangle. So here to the left we have the triangle with the given side C, side A, and angle C. And in this triangle, let's call this angle A sub 1, the top one B sub 1, and the side B sub 1. Then, when we will solve the second triangle, we will call these dimensions A sub 2, B sub 2, and B sub 2. Now, because in this triangle we know side C and angle C, and we know side A, we can find angle A sub 1. So, we will use the law of sines. A over sine of angle A sub 1 equals C over sine of angle C. Now let's replace 89.45 over sine of angle A sub 1 equals 37.36 over sine of 15.62 degrees. We will use cross multiplying to multiply sine of angle A sub 1 by 37.36, then we will multiply these two. So then 37.36 multiplied by sine of angle A1 equals 89.45 multiplied by sine of 15.62 degrees. We will divide both sides by 37.36. On the left side, these two numbers will cancel. And now to find the angle A sub 1, we will take the sine inverse of this expression. Then A sub 1 equals sine inverse of 89.45 sine of 15.62 degrees over 37.36. Then A sub 1 equals approximately 40.14 degrees. Now, once we know angle A sub 1 and C we can find angle B sub 1. B sub 1 equals 180 degrees minus the sum of 15.62 degrees and 40.14 degrees. Then angle B sub 1 equals 124.24 degrees. Now, once we know angle B sub 1, we can find side B sub 1. For this, we can use that C over sine of C equals B over sine of B. But if we wanted, we could use A and sine of A, because at this point we know both side A and angle A sub 1. I will use B sub 1 over sine of B sub 1 equals C over sine of angle C. Then B1 over sine of 124.24 degrees equals 37.36 over sine of 15.62 degrees. We will use cross multiplying and we will get B sub 1 times sine of 15.62 degrees equals 37.36 times sine of 124.24. Then we will divide both sides by sine of 15.62 degrees. We will cancel them on the left side. Then B1 equals approximately 114.7. Now, as you see here, we found angle A sub 1, B sub 1, and side B sub 1. Next, we will work on finding the dimensions of this triangle. We still have angle C, which is 15.62 degrees. We have side A, which is 89.45, and side C, which is 37.36. We will find angle A sub 2, B sub 2, and side B sub 2. If we start by finding angle A sub 2, we can use C and sine of angle C, and side A and sine of angle A sub 2. However, this is exactly what we did above when we found angle A sub 1. This angle A sub 1 is an acute angle, however, A sub 2 is an obtuse angle. To find angle A sub 2, let's look at the unit circle. In this unit circle, let's draw angle A sub 1. This angle has the measure of 40.14 degrees. Now, this point on the unit circle has the coordinates x and y, and we know that y represents the sine of this angle, and y is also the right side of this triangle. But there is another triangle in quadrant 2 whose height is the same as the height of the triangle to the right. So if this point has the coordinates x and y, then this point will have the coordinates negative x and the same y. So if sine of this angle equals y, then sine of this angle is also y. Finding this angle means finding angle A sub 2. We find this angle by subtracting 180 degrees and 40.14 degrees. So then, A sub 2 equals 180 degrees minus 40.14 degrees, and angle A sub 2 equals 139.86 degrees. And this indeed is an obtuse angle. Now, once we know angle C and angle A sub 2, we can find angle B sub 2. B sub 2 equals 180 degrees minus the sum of 15.62 degrees and 139.86 degrees. Then b sub 2 equals 24.52 degrees. Now in the last part we will find side b sub 2. For this we can use side C, angle b sub 2, and we will find side b sub 2. So b sub 2 over sine of b sub 2 equals C over sine of angle C. B sub 2 over sine of 24.52 degrees equals side C, which is 37.36, over sine of 15.62 degrees. Then b sub 2 multiplied by sine of 15.62 degrees equals 37.36 multiplied by sine of 24.52 degrees. We will divide both sides by sine of 15.62 degrees. On the left side they will cancel. Then b sub 2 equals approximately 57.58. So now we have the dimensions of the second triangle. We have angle a sub 2, angle b sub 2, and side b sub 2. And now the whole problem is completed. We had two triangles and we found the dimensions of both of them. Here we will be done with this lesson. This is section 9.5, Oblique Triangles, the Law of Science. Thank you.